Dear all, welcome to the class on logic operations and shift operations. In this particular lecture, we will try to cover the topics, that is logic operations and the truth table for the logic operations, what are the hardware implementation for these logic operations, and then we will discuss the applications for these logic operations. And then finally in this class I will cover the shift operations and the different types of shift operation available inside the computer hardware. So let us start with the definition of logic operations. As you know that central processing unit is having the mainly three components, that is arithmetic logic unit, control unit, and the registers. So arithmetic and logic unit, basically it is responsible for performing the different arithmetic and logic operations inside your systems. So logic operations, as we know, they are also called the logic micro operations. Saying them micro operation is the reason for that is that they are implemented at the lowest level, means they are implemented at the bit level within the registers of the CPU. That is why they are also called the logic micro operations. So they specify the binary operations for a string of bits stored in a register. You know that within the CPU there are many different type of registers are available. So for example, if we take that register R1 is there and register R2 is there, so what, and we are taking the example of this exclusive OR. This is the symbol for exclusive OR operation. So what this will do, basically this statement is all about that the content of the register R1 and the content of the register R2 bit by bit they will be exclusively OR, and finally the result will be transferred to the register R1. So this is the statement, and make sure that this particular statement is only valid when your control signal P is active. So exclusive or micro operation with the content of two register R1 or R2 is symbolized by the following statement. Now let us try to understand this particular statement with the help of example. So the example is that we assume that the content of the register R1 is 1010 and the content of the register R2 is 1100. Now what will happen? The individual bits of the register R1 and the register R2, they will be exclusively OR. So you know that exclusive OR operation, what it does, when the two bits are same, means they are both 0 as in the example, so it will give you a result 0, means the exclusive OR of 0 with the exclusive OR of 0 is 0. And similarly, look at this leftmost bit, which is also most significant bit in this case, 1 1, means they are same bit, so result is again 0, means exclusive operation gives you the 0 when the bits are same. So 0 0 it is 0, 1 1 it is 0. But in the intermediate second and third position, you can see here that 1 0 and again 0 1. So the result outcome of these particular two operations means 1 0 it is 1, 0 1 it is 1, because the bits they are different, it is 1 0 and it is 0 1. And now what will happen, finally the contents of the register R1 after this particular operation is now 0110, means the content, earlier content 10 and 10, they are no more in the register R1, they have been replaced with the content 0110. But one point you have to emphasize here, that the content of register R2 is not going to change in this particular statement. Now after understanding the operational detail of this particular operation, now we move on to what are the utility of these logic micro operation. As the statement is written on the slide, that the logic micro operations, they are very seldom used in scientific computation, means they are least used in scientific kind of computation, but they are really very handy for the bit manipulation of binary data, and especially in the decision making situations. So now we move on to the next slide. It is the list of logic micro operation. This is a very good slide before you, that you can see there are different logical operations listed in this particular slide, starting from F0 going to the F15. In total they are 16. So now you can see here that F0, it represent here in this table is a clear operation. Clear means when you want to make everything clear inside your register. Means generally it is implemented by putting every value by 0. And the second micro operation is a logical AND operation. As you can see that XY, F1 is XY. Similarly, the transfer A. Similarly, this F6 is representing what we just understood in the previous slide. X XOR Y, that is exclusive OR, and then NOR, then complement B, then complement A, then NAND, and set to all one. Means this is the list that is showing the different logic micro operations. Now we move on to the next slide. Now we move on to the next slide, which is the truth table of the logic micro operations, what we just see in the previous slide. So we saw in the previous slide that there were 16 logic micro operations F0 to F15. So as we saw that F1 was representing in the previous slide AND operation. So now you can see that when X and Y, these are the two binary variable, so they may take the value from 0, 0, 0, 1, 1, 0 and 1, 1. So you can clearly verify that your AND operation here in this list F1 is a logical AND operation. So AND operation gives you 1 only when both the input are 1. Otherwise, in all the rest of the three cases, it will give you 0. And similarly, you can verify the other logic micro operations in this particular truth table. Now we move on to the next slide, hardware implementation. So it is also very important that when we are having different kind of logic micro operations, as we saw just in couple of slides earlier, that there are 16 ranging from F0 to F15, including the clear or logical and logical or exclusive or all set to 1, NOR, means there are 16 in total. So now in this particular slide, we will try to understand how they can be implemented in hardware. So the hardware implementation of logic micro operations, it requires that logic gates be inserted for the each bit or the pair of bit in the register. Make sure it has to be inserted for the each bit or the pair of bit inside the register to perform the desired logic function. So as we know that there are 16 logic micro operations, what we just saw earlier. So most of the computer, they only use the four basic, which is the logical AND, the logical OR, the logical exclusive OR, and the complement. And for your kind information, all other logical micro operations, they can be implemented just by making use of these four: AND, OR, XOR, and the complement. Now we move on to the next slide. It is very interesting one. Now the very important question arises here, that what are the different applications. So as dear friends, I told you in the beginning of this particular lecture that arithmetic logic unit, which is, you can say, the very central part of the CPU and which is responsible for performing all arithmetic and logic operation. So by extending that particular statement, the applications for these logic micro operations are very useful for manipulating the individual bits. They play a very vital role inside your CPU when you really want to manipulate individual bits. You may ask the questions, what are the different requirements when we are interested in changing or manipulating. So there are many situations where you really want to change the state of a register, or when you want to change the meaning of any control signals. So there are plenty of situations where you want to really change or manipulate the individual bits so that finally you can change the desired result. So they can be used to change the bit values, delete a group of bit values, or inserting the new bit values for accomplishing the desired result. So this is all about the applications of your logic micro operations. Now we move on to the next slide, which is the shift operation. So up to this moment, friends, we have covered the logic micro operation, and now the other half of this lecture I will devote to the shift operations. You know that shift operations, they are also They are also called micro operations for the reason stated as I earlier for the logic micro operation. The same reason goes for them also. Shift micro operations are used for serial transfer of the data. Very important. 9. They are used for serial transfer of the data. The content of the register, they can be shifted to the left or to the right depending upon the requirement. So during the left shift or shift left operation, make sure your serial input transfer a bit into the rightmost position. Means when you are going to shift left, so ultimately your input will be transferred into the rightmost position, and vice versa. Vice versa means when you are making a shift right operation, so your bit will be transferred into the leftmost position. This is but obvious. So now we move on to the next slide, which is showing the very good information, that is the type of shift operation. So if we categorize or if we define the type of shift operation, then we may say that there are three different types. One is logical shift, another is circular shift, and finally it is the arithmetic shift. So now in the coming slide, we will try to understand each one in detail. So let us start with the logical shift. You know that logical shift is one that transfers the zero through the serial input. As I told you that logical in means shift operation, they are used in the serial input, transferring the serial input. So a logical shift is the one that transfer the zero. Make sure it transfer only zero through the serial input. So now generally SHL it is used to represent the logical shift left, and SHR it is used for representing the shift right micro operation. So let us try to understand with this statement that SHL R1 to R1. The meaning of this statement is that the contents of the R1, they will be logically shift left and the result will be transferred to the R1. Similarly, SHR R2 to R2 means the contents of the R2 will be logically shifted to the right and the content will be transferred to the R2. It means the older content of the R2 will be removed. Now the next, it is the circular shift in the category. The circular shift, which is also known as the rotational shift or rotational operation, it circulates the bits around the register, inside the register, without losing the information. Make sure circular shift, it circulates the bits of the register around the two ends of the register, but ensure that there is no loss of the information. This is accomplished by connecting the serial input of the register to the serial input. Means the serial input and output, they are connected so that the rotation operation can be performed and without losing the information as stated in the definition of the circular shift. So now we move on to the last category, which is the arithmetic shift. So dear, you know that arithmetic shift is a micro operation that shift a signed binary number to the left or right. Make sure it shift a signed binary number to the left or to the right depending upon the requirement. As we are seeing in this particular example, that this is showing the arithmetic shift right. Arithmetic shift right means here it is your sign bit Rn minus 1, which is you can say MSB, most significant bit, and then Rn minus 2 next to it, and the R0 in the example, it is the you can say rightmost bit, and according to convention it is also the least significant bit, which is also called LSB. So what this arithmetic shift right will do, it will shift the content of this particular register to the right, and it will not change the content of the sign bits. Generally 0 is represented for the positive number and 1 is for the negative number. For your kind information, the negative numbers, they are generally implemented through the 2's complement representation. So now try to understand how this arithmetic right shift will take place. Let us say these are the earlier contents, older content of the register, or if I say now during the arithmetic right shift, this R minus 1 will be shifted to the right, means the R minus 1 will shift it to here, R minus 2 here, and finally R1 will go to in the position of R0, and R1 will be lost during the process. Make sure, sorry, R1 will go to the R0 and R0 will be lost during the process. As I am telling you that during the arithmetic right shift, the content of the sign bit, they will be shifted. Yes, sign bit will also be shifted, but the content of the sign bit will not be changed. And finally, the rightmost bit, which is also called the least significant bit, it will be lost during the process. So ultimately, if I say arithmetic shift, what it does, whether it is a arithmetic left shift or right shift, basically your arithmetic right shift, it divides the number by 2. As you can see here, that when your R0 bit is lost, so during that process the overall arithmetic value of this particular register will be just half of the previous value. Similarly, if we assume the arithmetic left shift, then arithmetic left shift will go from this direction to this direction, and finally the outcome will be the double the value of the original number. So this is the meaning of the arithmetic shift. Now we move on to the next slide. It is showing you the list of different shift micro operation. You can see, as I just told you a couple of slides earlier, that SHL, it is used for shift left or register, it is shift or register, shift right, it is CIL, circular shift left, CIR stand for circular shift right, ASHL, arithmetic shift left, ASHR, arithmetic shift right, just what we understood in the previous slide with the help of a diagram. Now, these are the references what I used for preparing the content of this lecture, and finally, thank you so much.